Hello. Hi, Mark.
Hello.
How's it going?
Going well. How about yourself?
Good, good. Welcome to the course. I'll go ahead and share my screen for now. Hello. How are you guys doing? It's good. It's good. All right, it's 2:30, so let's go ahead and get started. All right, good afternoon, everyone. Welcome to the spring 2022 semester, and welcome specifically for this class, which is EGME 407, Introduction to Heat Transfer. Right? So my name is Professor Justin Tran, and I will be your instructor for this semester. And before we get started, let me just say it's great to have all of you in the class. I know we're virtual for what feels like the bajillionth time since this pandemic began, but it's always great to see all your names and see the number of participants in the course go up. So welcome to all of you. Hope everyone had a great winter holiday. I know this is not the ideal start of the semester that we wanted, but we got to do what we can to keep everybody safe. Okay. All right, so the plan for today is I'm going to give just a brief introduction to the course. And we're going to talk about the syllabus, and then I'm going to give you a tour of the course website as well. Okay, so it's just the first day, and we're all virtual, so I didn't want to cover any content today, and so it's just going to be introduction stuff. So just to give you an idea of what the class is all about and all like the logistical information that you need for the class. Okay. But before we get started, are there any questions I can answer from you guys, about anything, about the class, about how the semester is going to go, the virtual teaching, or anything? You can either turn on your mic, or you can put your question in the chat, and that either of those is fine with me. Okay. All right, so I'm not seeing any questions, and so let's just go ahead and get rolling. Okay, so a little bit about myself. So just like I said, my name is Professor Justin Tran. My office is in the computer science building, which I think confuses people a lot, but there are no open offices in engineering. So, and I'm still relatively the new guy in the department. So they kind of stuffed me at the top of the CS building. So my office is CS 526. Of course, I'm not there right now. So since right now, we're all required to be home. So I'm in my apartment. But after the 2 weeks are up, then I'll start coming to campus. You can find me in that office. Okay. My email address is justran@fullerton.edu. I always tell people it's really easy to remember because you can just say that I just ran a 5K or just ran a mile, right? And that's my email address. Okay. I always joke that maybe I stole the email address of a running club here at Fullerton, but I haven't gotten any angry emails from runners yet, so I'm just going to keep it the way it is. Okay. I grew up around here, so I'm pretty local. So I've known this area my whole life. So I grew up in Cypress. So if you're not aware where that is, that's about 10 miles west of Fullerton. So it's kind of just south of Cerritos. I think people generally know where Cerritos is. Okay. A bit about my educational background. I got my bachelor's from UCLA. I did my master's at UCSD, and my PhD was at Stanford. So it was all in mechanical engineering. So, I've been in mechanical engineering, my entire life. Okay. In terms of my research interests, a lot of my research focuses on kind of the intersection between engineering and biomedical sciences. In particular, I study heart and blood disease. Okay, so I use engineering tools to simulate blood flow and use that to study cardiovascular disease. And just naturally, just as an instructor of STEM, I'm interested in better ways to teach STEM education as well. Okay. And I didn't mention this before, but a lot of my courses, I welcome questions at any time. I do pause to ask if there's any questions, but if you have a question anytime, please don't hesitate to turn on your mic or throw a question in the chat, and I'm always happy to answer. Okay. Okay. Learning objectives, and so you'll be seeing this throughout the entire semester. So one thing I always like to do before every class is to talk about what our objectives are for the day. Okay. And so what the learning objectives are, you can think of them as almost like kind of like a preview of what you can expect to learn on that day. Okay. And so I love these because I think they really help organize the content. And they really help organize the content around the students. And so, teaching, I think at its core is to basically impart knowledge onto our students and have them learn those skills and demonstrate those skills and use them in their professional workplaces. And so when I prep a lesson, when I prep a lecture, I always think about, what are the things I want my students to get out of this lecture? What do I want them to be able to do, after the lecture is up? And I summarize those in the learning objectives. Okay. And so what you'll notice about the learning objectives is that most of the time they're going to start with some kind of verb. Okay. And so here, we have 3 learning objectives, and they're all fairly simple, and they all start with a verb, right? And I do that on purpose. And the reason I have them start with the verb is I want you guys to be able to learn some actionable skills that you can demonstrate after the lecture. Okay. And so after today, you should be able to list applications of heat transfer. Okay. And I love this because it's a great way for for you to kind of check your own learning as well. Okay. And so what I always recommend to students is that you, at the beginning of the lecture every day, to write down the learning objectives at the top of your notes. And then once the lecture is done, go back to your learning objectives and see, can I do this task that, Professor Justin or Professor Tran said that I can do. Okay. And so after today, if you can list all the applications of heat transfer, then that's great. Then you got everything out of the lecture then that I wanted you to do. Okay. I also like this too because I grew up playing video games a lot, and I almost think of this as like a quest list, right? And so these are all the quests that we're going to accomplish by the end of today. Okay. Oh, another thing I forgot to mention. I know I listed my name here as Professor Justin Tran, but I'm very I don't mind anything that you want to call me. So I've had students call me Professor. You can have students call me Justin. They've called me Dr. Tran. Whatever's comfortable for you is comfortable for me. Okay. I put this offer out there for every single semester, but so far no one's taken me up on it. But you can even call me like dickhead or something like that. Okay. And I'll respond to that. Okay. So I grew up in the era of online gaming, so I've been called many worse things in my life. So nothing you can call me will offend me. Just maybe don't do it in class because if you're being disruptive with it, then I'll probably kick you out of the class. Can you call me Susan? Sure. I don't know what that means, but if it makes you happy, you can do that. Okay, so let's talk about the course now. And so let's talk about, what is heat transfer and what can you expect to learn throughout this entire semester, okay? And so if you look up a book definition for heat transfer, actually this is the definition that's given in the textbook, right? And so heat transfer is the transfer of thermal energy that is in transit due to spatial temperature difference, okay? So that's a great definition. It's very descriptive. It's very succinct, okay? But it also has kind of a lot of jargon in it, and I always hate it when the first impression you have for a class is some very obtuse sentence that has words that you may not know, right? And so I'd like to come up with a very much simpler definition for heat transfer. And so if anything else during this class, I want you to always remember this, that heat goes from hot stuff to cold stuff, okay? And so whenever you have two objects, and so one is hotter than the other one, okay? and we know what hotter means because that's, that means it has a higher temperature, then heat or energy is going to go from the hot thing to the cold thing. Okay. And this is always true. Okay. And so that's, as long as you always remember this, you're going to be in good shape for this class. Okay. All right. So let's talk about some examples of heat going from hot stuff to cold stuff. Okay. And so let's talk of an example of a drink cooler. Okay. And so you've probably seen one of these if you've ever gone to, maybe you've gone to the beach, or maybe you've gone camping or something, and you've wanted to keep your beverages cool, right? And so probably what you did was you went to the gas station, you got a big bag of ice, you unloaded it into your cooler and put all your drinks inside. Okay. And so what you have here is a temperature difference, right? And so if you look at, let's say that we have this Mountain Dew, the nectar of champions. Okay. And so if we have the Mountain Dew, and let's say you just bought it from the gas station, right? And so the Mountain Dew is going to be warmer than the ice, right? So the temperature of the Mountain Dew is higher than that of the ice. And so what's going to happen here is that heat is going to flow out from the Mountain Dew and into the ice. Okay. Right. And as that process occurs, and so as heat leaves the Mountain Dew and goes to the ice, the temperature of the Mountain Dew is going to go down. Okay. And that's heat transfer. Okay. And so heat transfer is, whenever you have heat that goes from a hot thing to a cold thing, right? And that's true for the root beer, for the Dr. Pepper, the Coke, and the Canada Dry as well. Okay. Okay. And so another example that you've probably seen a lot, especially if you are a poor college student and you make ramen all the time, like I did, is boiling water, right? And so in this case, we have in this case, a very cool, clear pot, which has water. Okay. And so if we draw kind of a little box around the water, we can see that, the water is going to be a lower temperature than the fire, right? Okay. And so because the water is a lower temperature than the fire, then heat is going to flow from the fire into the water. Okay. And that heat that flows into the water is going to cause it to heat up and eventually boil once it reaches the boiling point of the water. Okay. And so again, a very simple example, but I think it illustrates the ideas of heat transfer really well. Okay. Another example that you might be familiar with, especially as a starving college student, right, is heating something up in the microwave. Okay. So microwaves are really interesting because it utilizes radiation heat transfer because it uses the microwaves inside the microwave to heat up your your food item, okay, which I guess in this case is a Big Mac. Okay. And so just like before, we have heat that's being generated by electricity in this case. Okay. And it's going to cause the outer surfaces of the microwave to heat up, and that's going to cause heat to flow in. Okay. And heat up your food. Okay. Okay. So always remember, heat goes from hot stuff to cold stuff, and you're going to be good in this class. Okay. Where heat transfer becomes more difficult is actually computing how much energy is actually transferred and at what rate it's going at. But the core idea of heat transfer is just heat goes from hot stuff to cold stuff. Okay. Okay. And at this point, I want to turn to you guys. And so what are some other examples of heat transfer that you've seen maybe in your daily life, or maybe an engineering example of heat transfer? So I'll go ahead and open the floor to you guys. So you can go ahead and turn on your mic if you feel comfortable. If not, you can put it in the chat and then I'll read it out loud.
An example that I might have. Oh, sorry. You go right ahead. You go right ahead.
The machine that heats up the that overheats the coffee, which in turn overheats my mouth.
Great example. Yes. Any kind of hot drink dispenser, yeah, there's going to have like you said, a copper coil, and that's going to heat up and heat the drink. Yeah, great example. And there's another one that
yeah, a heat sink like on a CPU or any type of chip.
Great example. Yeah, I'm actually going to talk about that more a bit later, because electronics cooling is a huge area of interest for the electronics industry. So yeah, great example. Right.
An electric kettle. Electric kettle,
yeah, awesome. Yeah, great example. Yeah, another great example of heating up heating up water and heating up drinks. And that's I think something that most people have in their kitchen, just because everyone wants like a hot cup of hot coffee, a cup of hot tea, hot chocolate. Very useful device that's used on a daily basis. Yeah. Any others?
Space heater, maybe.
Space heater, great example. Yes, actually, I have one on right now because it's really cold in my apartment right now.
Yeah, same. Same.
Yeah. No, great example. Yeah. All right. Yeah, great example. So, heat transfer is great because, and I would say that all, at the risk of angering other professors, all engineering classes that you take are really cool. But I think in terms of a class that I use and I see every single day of my life, I think heat transfer is the one of the most useful. And what you'll see that, as you start taking this class, as we get along in the semester, you'll see that, you'll be able to see a lot of these ideas, take place in your daily life, because temperature regulation and regulating, how much heat goes into and out of stuff, it's a huge part of the design of so many things in your life that I think you'll see. Okay. So now let's talk a little bit about how heat transfer happens. Okay, and so I think this this little spider graph is going to be helpful. And so if we have kind of heat transfer in the middle here, and so that encompasses all of heat transfer. Okay, there are three primary ways that heat transfer happens. Okay, and what I like to call these are basically called the modes of heat transfer. Okay. Right, and so we have three of them. And so we have conduction, we have convection, and we have radiation. Okay. And so just very briefly, I'm gonna give some definitions about what each of these three terms mean, just because they're kind of core terms for the class, and I'll give some examples of them occurring. Okay, this is also really nice because it's kind of how the class is organized. So kind of I would say the first 40% of the class we're going to cover conduction, the second 40% of the class we're going to cover convection, and then the last 20%, kind of right before the final exam, we cover radiation. So, it's a very nice breakdown of these three phenomena. Okay, so let's talk about conduction. And so conduction will be the first mode of heat transfer that we cover, partially because it's the simplest, but also because it's one of the most common. Okay, and so the definition for conduction is that it refers to heat transfer across a stationary medium. And that medium can be a solid, a fluid, or a gas. And so there just has to be some kind of matter in between your two objects. Okay. The key word here is stationary. Okay. And by stationary, what I mean is that your medium is not moving. Okay. And that's really important because if the medium is moving, and so let's say you have a moving fluid or like moving air, moving water, then it becomes convection, and then we'll talk about that later. But conduction specifically refers to two stationary objects exchanging heat with one another. Okay, and the primary way that the heat or that energy transfers in conduction is through molecular heat transfer. Okay, and so what happens is that excuse me, my voice cracked. And so when you have two things that are next to each other and they're stationary, right? Every object of matter is made up of molecules, right? Atoms or molecules, okay? And so in conduction heat transfer, basically what's happening is that the molecules, which are next to each other, they're going to be exchanging energy with each other, okay? Right, and so in this simple example here, let's say that we have a top plate right here, and this top plate is hot, okay? And then on the bottom here, we have a cold plate, okay? And so such that T1 is greater than T2, right? What's going to happen, just like we talked about before, heat is going to flow this way, right? Because we have a hot object and a cold object. But the way that heat gets transferred is that the molecules in between, they exchange energy with each other, okay? And so, this molecule has more energy than this one because it's closer to the hot plate. And so some of that energy, literally gets kind of transferred from one molecule to the next, okay? And then once that energy gets transferred here, this molecule becomes a little bit more energetic, and that transfers energy to the next one, okay? And so it's a molecule by molecule, transfer of energy, okay? And so that's conduction. Some examples of conduction. And so I have one here where, if you have kind of a hot cup of water or hot cup of tea, and if you've ever stuck like a metal spoon inside it, okay, eventually what you'll see is that, if you leave the spoon in there long enough, then your fingers are going to get burned, okay? And the reason for that is because, because the spoon here is stationary, okay, and it's made of metal, which has an impact that we'll talk about probably on Wednesday, okay, then heat is going to travel up the spoon, okay, because the molecules on this side of the spoon, which is inside the hot water, they become heated up from the hot tea, okay, and that's going to transfer energy to all the adjacent spoon molecules up until it travels up to your hand, and then you burn your hand, and then you yell curse words at the tea, okay. All right, another example of conduction is through human contact, right? And so if you ever held hands with someone, and one person has colder hands than the other one, you kind of know right away, right? And so, you might hold hands with someone and their hands might be really cold, and you'll be like, what the hell, man? But that's another example of that, right? So as soon as your hands make contact, right, then the molecules from one hand will be in contact with the molecules of the other one, and then heat can transfer from one to the other one, okay? And so these are a couple examples of conduction, okay? Any questions on conduction? Okay. All right, so let's talk about convection really quickly. So convection refers to heat transfer between a surface and a moving fluid, okay? And again, the key word here is moving, okay? Right? And so whenever you have air that's flowing over an object, or you have water that's flowing over an object, right? And so if you have some kind of moving fluid, there's convection that can occur, okay? And so the difference between convection and conduction is that because of this movement, because the fluid is moving past the surface, that's always going to enhance heat transfer, okay? And so if you compare kind of a two situations where on one hand you have just a stationary fluid, so you just have pure conduction, versus the same situation with a moving fluid, okay? The convection is always going to be higher, or the amount of heat transferred is going to be higher in convection than in conduction, okay? And the reason for that is because of this bulk movement of molecules, okay? And the way I like to think about it is like this, okay? And so when you have a moving fluid, and so let's say you have air, okay? Let's say that the air is cooler, okay? Then so heat is going to escape from the surface, right? And so let's say it's a really windy day outside, and the wind is blowing past you, right? And you've probably heard of the term wind chill, right? And so whenever you have wind chill, it always feels colder than it actually is, okay? And the reason for that is because the wind is blowing, it actually speeds up or enhances the amount of heat that's leaving your body strictly because of the bulk movement, okay? Because normally if you have just pure conduction, the heat's going to leave your body, and that heat is just going to stay here, okay? Just like we talked about, the molecule of the air that's next to your skin, that might heat up a little bit from your body, and then it's just going to stay there, okay? But because this molecule is already kind of heated up, that kind of makes it a bit harder for more heat to leave, okay? But if you have a moving fluid, okay, once this molecule kind of heats up right here in the air, then the wind kind of pushes it away, okay? Right? And so what takes its place is a newer cold molecule, okay? And so because we have this bulk movement, that's going to enhance the amount of heat transfer that occurs, okay? And so actually some people argue that there's actually no such thing as convection. It's all just conduction. It's just that with the moving fluid, it kind of puts more fresh molecules closer to the surface than before, okay? All right, so some examples of convection that you might have seen in your daily life. Oh, question? So can tempered glass be used as an insulator? Yeah, it can. And so glass is a relatively insulating material, and so heat doesn't go through glass super well, and so it can definitely be used as an insulator. But we'll talk about that more probably on Wednesday, if not on Monday, because the material that you use for heat transfer actually does make a huge difference in how much heat gets transferred. But and so I'll give you a more full answer to that question later on. Okay, so some examples of convection heat transfer. So you've probably done something like this. Okay, so if you have a hot bowl of soup and you want to eat it without destroying the roof of your mouth, you'll probably blow on it, to help cool it down. Okay, and so what you're doing, so it's interesting because when you blow air out of your body, the air from inside your body is probably actually warmer than the air outside in the air. Okay. But the reason we do this is, because we're creating convection heat transfer, okay? And so by creating a velocity of fluid over the spoon, you're going to enhance the amount of heat that's getting lost from the hot soup. So it'll make it easier for you to eat it, okay? And on the right here, we have Windshield, okay? And so Windshield is interesting because, I think the way that that a lot of people think about wind chill is that, they might say, oh, it's like 40 degrees outside, but with wind chill, it's 25, okay? And so, that's a little bit of a misnomer because, wind doesn't actually make the temperature cooler. It just feels like it's cooler, okay? And the reason it feels like it's cooler is, just like we talked about, the wind is enhancing the amount of heat transfer or the amount of heat that leaves your body, okay? And so when they say it's 40 degrees with wind chill, it actually is 40 degrees. And so the wind isn't making it colder. It just feels like it's colder because your body is losing heat at a more rapid pace than no. Okay. All right. Any questions on convection? Okay. And a lot of this information we'll go over again, especially once we get to the respective units. And so this is just to kind of introduce the ideas to you, because these are kind of the three central ideas of heat transfer. Okay? All right, so the last mode of heat transfer we have is radiation. Okay, and so radiation is really interesting because it's the only mode of heat transfer that does not require a medium. Okay. Okay, and the reason for that is radiation is heat transfer that occurs through electromagnetic waves. Okay, and so electromagnetic waves is another way of saying light. Okay, and so in the same kind of mechanism that causes light to travel from one place to another, radiation uses that same mechanism. Okay, and so that's what I mean by electromagnetic waves. Okay, and so radiation is always occurring, and so as long as your body has some kind of temperature. And most things do, because when I say temperature, I mean it's not absolute zero. Okay, all bodies are going to radiate heat. Okay, but if you compare radiation to conduction and convection, usually radiation is a lot smaller in magnitude than the other two, and so that's why we kind of save radiation for last. Okay, because usually a lot of times we kind of just ignore it in our calculations because it's pretty small. But radiation does have a lot of really I won't say niche, but I say a lot of specialized applications, especially if you're going to get into aerospace or energy applications. Okay. Okay. And so one example of radiation that you see every day is the sun. Okay. And so, if you know anything about space, you know that there's no matter in between sun and earth. So it's just empty space. Okay. So it's not even air. Okay. And so the only way for the heat from the sun to reach the earth is through radiation. Okay, and so heat leaves the sun through radiation and it comes and warms up the earth. Okay, another common form of radiation is through a fire. Okay, and so a fire is very hot, and so a lot of times a lot of the energy that comes off of fire is through radiation. Okay, but again, if you're not doing aerospace applications, a lot of times radiations you can kind of ignore it. But it is important to know what it is to, just for those applications. Okay, I will say that we're not going to cover radiation in too much detail because it's a very very rich area, very detailed, very complex area, and we're only going to be able to just do the basics. But we do have more advanced heat transfer classes where you can learn more if you're interested. Okay. All right. Any questions on radiation? Question. Question. So how big of an impact does radiation have on aerospace? Yeah, no, it's a great question. And so, the primary reason radiation has an effect on aerospace is that, once you have a vehicle that leaves Earth's atmosphere, so whether it be like a rocket or a satellite, most commonly, the only heat transfer you have to deal with is radiation. Okay. And that makes it actually really complicated because, if you think about it, you have a satellite that's orbiting Earth. Okay. Okay, that's my satellite. Don't hate on it. Okay, so that satellite most of the time is going to have some electronics on board that are going to be operating, right? And those electronics are going to be generating heat. Okay, and so one common problem that a lot of especially bigger satellites with more intense electronics, a big problem that you're going to have to deal with is how do you offload that heat from the satellite, okay? And it's very different, right? And so, you might not think about it a lot on Earth because, we're surrounded by air, which is a great heat sink. But in space, there's no air for you to have convection or conduction, okay? And so the amount of heat that you can offload to the surroundings is a lot of times very minimal because the only way that you can do it is through radiation, okay? And so the thermal design of satellites is really interesting because they have to account for these things. So you have to design a lot of heat sinks on the satellite, and they have to work really well with radiation just so that your satellite doesn't melt itself, okay? Another application with satellites is, they have to power themselves, right? And so a lot of ways these satellites power themselves is through solar panels, right? And so you have to design those solar panels to maximize the amount of radiation heat transfer that you get from the sun, okay? Question, so are spacesuits being white also to help with heat? Yes, I'm sure that's a consideration. I can't say that I'm enough of an expert to really comment on that, but I'm sure that's a big consideration because the color of the object has a big impact on how much radiation you take in or reflect. Yeah, I think I've seen the orange ones too. But yeah, I wish I knew more to really comment on that, but I'm sure it has an impact because radiation has a lot of similarities with optics, and so if it can reflect a light beam, it can reflect a radiation beam as well. So I'm sure that must be a big concern. Yeah. All right. Go ahead and clear this. Okay. Okay. And so if we come back to our little flow chart, or I guess our little brain blast diagram here, because we have our three modes of heat transfer. Okay. And if I can expand this a little bit more, this is going to give us basically an outline for the class, okay? And so all of these are kind of the different subjects or the different topics that we're going to cover in this class, okay? And so I know a lot of this means absolutely nothing right now, and so I don't expect you to know what everything on here means. If you do, you probably shouldn't be in this class. You should probably be in a more advanced class. But hopefully throughout the semester, more of this will make sense to you, okay? And so I think it's always fun to, I always show this for all my classes. I show kind of the big breakout diagram, just so that you can kind of return to this later and say that, yeah, I understand all these connections in between the different topics as well. Okay, but this is where we're going to go in this class. Okay. Okay, so very briefly, I'm a little bit behind today, but I do want to talk about why heat transfer is important. Okay, so heat transfer, I think, is one of the most important aspects of engineering, okay? Because a lot of it has to do with energy efficiency, okay? And so, if you take some of these numbers, right? And so, a lot of the energy that we use, and as humans, we use a lot of energy, okay? A lot of it is actually lost to heat, okay? So this number is a little bit old. I don't know how true this is, and with all the Teslas and electric vehicles, probably this number is a little bit better. But a lot of the energy that cars use, it's only a small fraction of the energy that they take in. Okay, and so if you take like a regular, a gas type car, okay, and so a typical car will only use about 21% of the energy that's in gasoline. Okay, and so you fill up, and so let's say that you fill up a tank, and your tank, just for easy, just for ease of calculation, let's say that you have a 10-gallon tank, right? And so the fact that cars can only use 21% of the energy, that means only 2 gallons of that gasoline is actually going towards propelling your car. Okay, the rest of that is lost to heat because it's as you make a combustion reaction, it's going to cause the engine to heat up, and heat is going to be lost to the environment. Okay, and so properly managing heat and properly managing, making sure the energy goes to the right places is a big concern for engineering. Yeah. Okay. And as our society gets more and more reliant on energy, making sure that we make efficient use of our energy and minimize the amount of heat loss is going to be critical. Okay. Okay. I have another video here. Actually, I need to stop sharing because I need to share with sound. Excuse me. Okay, and so like I mentioned at the beginning, I do like to play computer games, and so if you've ever gamed on a computer before, You know that cooling systems for your computer are very important. And so I want to show this video because I think it's really cool. I don't think we'll have time for all of it, but you know, I do want to show kind of the first few. And basically, this is going to show you how people have used heat transfer to upgrade their gaming rigs. Okay?
Having a badass computer is a must for many gamers, but besides the extraordinarily powerful source and a top-notch processor and GPU, everybody knows that a well-optimized cooling system is mandatory. In order to keep their rigs at the right temperature, people have come up with some pretty wild ideas, and in what follows we'll be presenting 10 of the craziest ways some modders try to cool down their precious PCs. A very resourceful user thought of a brilliant idea to cool down his computer, a turbine from 1990 Mitsubishi Eclipse. The turbocharger is able to move air through the PC so that it can provide the perfect cooling method, making it a weird yet effective way of keeping temperatures down low when overclocking your machine to engage in some really heated video gaming sessions. There's nothing human imagination and a little bit of ingenuity can't do. When it comes to innovation, the Russians surely take the grand prize, and this crazy modder stands as proof of that. He decided to keep his computer cool in some of the most ordinary, but yet creative ways by sticking it in the freezer. The nice part is that you'll have your fair share of polar air standing by in front of your rig, and this should be a blessing on a hot summer's day. In addition to that, the beer six-pack will be at arm's length, so we think that's a win-win situation. Why use only the original fan slots your computer comes equipped with when you can totally overkill and build an entire case out of them? When cooling down your PC, there's no overdoing it. You just have to be bold enough to step up and make an entire armor of plastic fans, glue them together and connect them to your main power source. And besides the practical side of this project, you'll also have the coolest PC in the neighborhood.
Let's do one more, and then we'll move on.
Some people believe that air flows better if you totally dismantle your machine and hang its components on some wires, making a modern art display out of them. It might not look like the most elegant rig in the world, but it does the job, and what's not to like about it? On the plus side, you don't need to add any extra gadgets like we saw in other examples from our list. This project can be done by everybody with a computer and a taste for extravagant setups.
All right, so there's a lot more to this video. It is really cool. So if you are into gaming, I recommend that you take a look. But yeah, you know, heat transfer is really big in these you know, in these in these applications. Yeah, it's interesting. I remember when I was in college, you know, I had my heat transfer instructor told me that you know, kind of the cutting edge right now in electronics is actually not in designing better chips. Okay. And so if you ask a chip manufacturer, you know, they can make stronger graphics cards. They can make stronger chips that you know, that have much better speeds. The challenge is actually in offloading that heat, because a lot of these chips just generate so much heat. And so, you know, in order to make more powerful chips, you know, they have to come up with smarter, more efficient ways to cool them. Otherwise, your computer's just going to melt itself, right? And so I've always found that interesting. I don't know how relevant that is now, because that was, you know, almost 8 years ago. But I do remember, you know, I think last year AMD set a world record for, you know, for the fastest clock speed on their processor, and they had to use liquid nitrogen cooling on their computer. So they made kind of a big show of it. So, you know, just to show you how important heat transfer is on that stuff. Okay. And lastly, you know, before we start talking about the syllabus, you know, heat transfer is actually really important in biology too. Okay. And so regulating the temperature inside your body is a really, really important job that I think a lot of us kind of really take for granted. Okay. Because temperature, you know, it triggers and regulates a lot of the important biological processes that happen in your body. Okay. And if your body temperature is even just a couple of degrees over what it should be, or a couple of degrees less, like you feel it, like you feel, you know, either really, really cold or really hot. Okay. And so your body actually has a lot of self-regulating mechanisms for doing just one thing, really, just to regulate the temperature of your body. Okay, so you can sweat to cool yourself down, or you can shiver to warm yourself up. Okay, and so, you know, like I said, you know, heat transfer I think is fascinating because it's something that you see every single day. It's just a lot of times we just don't really think about it. Okay, and so what I hope is that, you know, after taking this course, you'll start to see all of these really cool applications that say, you know, yeah, you know, heat transfer is, you know, something that I use. Okay, because I'll tell you, you know, for myself personally, you know, I don't do research in heat transfer, right? And so it's actually not really, I would say it's not a really big area of expertise for me. But I volunteered to teach this class. I told the department I wanted to teach it, because I see the connections in everyday life. Okay. And I think that's really cool. Okay. Oh wow, yeah. 450 watts, dang. I know people who would sell body boards to get a 3090. So yeah, it's cool. Okay, any questions on the class? Just the class overview before we start talking about the syllabus. Okay. All right, so I'm going to go over the syllabus, and so if you want to follow along, I do have the syllabus posted on the course website, and so you can of course feel free to follow along. But I'm going to go over all the main components here. Okay. Okay, so let's talk office hours. Oh, that's a typo. And so my office location is CS 526. But I think a lot of people will probably attend during Zoom. Okay, so office hours this semester will be interesting because I after these first 2 weeks, I'll physically be in my office, but I will open up Zoom. And so if you want to attend office hours on Zoom, that option will always be available to you. Okay, and so you can find links to all the office hour Zooms on the course website. Okay. And here are all the times. Okay, so office hours had one this morning. So office hours on Mondays, 11 a.m. to 12 p.m. I have one Tuesday morning. So Tuesdays, 9 a.m. to 10 a.m. And then Thursdays from 1 p.m. to 2 p.m. Okay, and so I try to vary my office hours, and so I try to have them on 3 days of the week, and I try to vary the times as much as I can, so to give everyone a chance to come to office hours. Okay. And I know that even with this, there are times when there are going to be some people in the class where these times don't work for anyone. And so for those cases, if you want to talk to me, then I'm always open to making appointments. Okay. And so, outside of these office hours, I do leave time. I do leave other times open to my schedule to meet with students. So, if you want to discuss something, you have questions on the homework or anything, and you can't make office hours, just shoot me an email and we can set up a time. Especially with Zoom now, it makes it even easier. So, I can do it from my apartment and you can do it from your home. So, it makes it really convenient. Okay. So office hours, for most people, I think people come to office hours to clear up points of confusion. And so if you have questions on the course content, you have questions on the homework or the exams, a lot of people come to office hours for that. But you can also come to office hours just to say hi. I've also given people career advice in office hours. So I've looked at people's resumes. So the office hours are for you guys. And so as long as it's relevant to your education, as long as it's relevant to your career, I'm always happy to talk about it in office hours. So please make use of these and come by and even just say hi and introduce yourself. Okay. All right, learning objectives. And so we talked about these before. And so, you're going to see learning objectives at the beginning of class every day, but I also have course level learning objectives. Okay. And so the course level learning objectives, these are objectives that are going to cover the entire course. Okay. And so by the time you're done with the course, you should be able to do these 4 kind of overarching statements. Okay. And I won't go through them now because, some of these won't make too much sense. But, definitely refer back to these as we go through the course to kind of help guide your learning. Okay. All right, so let's talk deliverables. And so right now I have 8 homework assignments planned. Okay. There are 2 midterm exams and 1 final exam. And so this is I think a pretty standard breakdown for this kind of class. Okay. I will drop the lowest homework because, I know it's a long semester and a lot of things happen, especially during COVID. And so, I always like to give my students the flexibility so that, you don't have to feel like you have to do every single homework assignment, otherwise you're going to fail. Okay, because I think that just adds a lot of stress, right? And so this dropping of the lowest homework assignment is is meant to give you some flexibility. Okay, but I do encourage you to do them all. Okay, and so the homeworks are there. I know everyone will disagree with me when you're doing the homeworks, but I don't assign homeworks to give you busy work. Okay, and so I assign homework very thoughtfully to really give you guys a chance to practice and really hammer in the learning. Okay, because I think it's one thing to listen to someone talk to you about heat transfer in the class for 3 hours every week, but a lot of these concepts and a lot of these these techniques, these skills, you have to practice them. And so the homeworks are there to give you the practice, to do those kinds of problems. Okay. And so that's the long-term kind of reason why you should do the homeworks. Short-term, the homework assignments are great practice for the exams. Okay. And so if you ever had me before, or someone that's had me, you probably have heard that I push pretty hard on the homeworks, and so I assign pretty tough problems. And so that's on purpose. And so, I really push you on the homeworks so that by the time you get to the exams, the exam problems are going to be easier. Okay. So the exam problems are always one step down from the homeworks. And so I always tell people that if you can do the homeworks and if you can understand them and every single step that comes into them, you're going to be in great shape for the exams, because the exams are going to be always easier than the homeworks. And the reason for that is, for the homeworks, you have a lot more time to do them. They're not in a stressful environment. And so I really want you to explore the material, grapple with the material to really learn it. Okay. Whereas on an exam, it's a very time constrained situation. And so you really only have enough time to just, write, just you're going to spend most of your time writing stuff down. And so, I don't want you to spend too much time, trying to figure out what the problem's trying to ask you to do. Okay. Because that's what the homeworks are for. Okay. But then again, if you don't do the homeworks, for me, it becomes very clear on the exams that you don't know what you're doing. Okay. And so even though I am going to drop the lowest homework, I do very highly encourage you to do them all. So even if you can't get it in on time, definitely still try to do, because they're all there to help you. Okay. All right, question. So is homework graded on completion or for being correct? Great question. And so I do kind of half-half. Okay. Because I want to encourage and reward everyone for doing the homework. And so if you complete every question on the homework and I can see that you gave an honest effort at it, that's going to be half the points right there. Okay. And so the other half of the homework is going to be graded on correctness. Okay. And so what I do is that I choose one problem on the homework at random most of the time. Okay. And then I grade that problem on the homework. Okay. And depending on how well you do on that problem, that's how you get the other half of the points. Okay. And so I like this hybrid approach because, I think it encourages everyone to at least give each problem a try. Okay. But I also kind of hold you accountable by grading it for correctness on that one problem. Okay. And I don't tell you what problems and don't ask me what problem I'm going to grade, because, I think that kind of defeats the purpose. But I also don't know either. A lot of times I sit down to grade and I'm like, that one, I'll grade that one. Okay. All right, so midterm exams are not going to be cumulative. And so, for the midterm exams, you're only going to have to be worried just about one section of the course, but the final exam will be cumulative. Okay. And here are all the dates for the exams. Okay. And just like I mentioned in the introduction email, even though this class, I still plan on conducting it over Zoom, for the entire semester. And so you can choose to attend the class virtually if you would like for the entire semester. The only days that I'm going to require everyone to be in class is for the exams. Okay. And so, please, mark these dates down in your calendar just to, just to make sure that you're going to be here on those days. Okay. And I don't have any plans for any makeup exams, unless there's kind of extenuating circumstances. Okay. And the reason for this, and the reason I'm requiring everyone to be in person, is that for me, it helps me keep the exams fair. Okay. Because what I've had to do over the pandemic is that, because of virtual exams, I can't stop you from looking at your notes and looking at the textbooks. I have to make them harder than usual. But if they are in person, and I know, and I can, and I know what materials that you can use, which is just a cheat sheet, then it helps me keep the exams fair, and it helps me, keep things, easier than the homeworks, which is kind of what I promised you before. Okay. So, since someone asked me this before the class, for every exam, I will give you a study guide. So there's a study guide that's going to be there for every exam to help you study. And I plan on giving you a review session for every single exam as well. Okay, so all of that's there to help you study. Okay. All right. Any questions on the homeworks or the exams? Okay. All right, so here's the course, here's the grade breakdown. Okay, so I have 20% of the grade on the homework, 20% for each of the midterm exams, and the final exam will be worth both midterms combined at 40%. Okay, so this is a fairly standard kind of breakdown for me. And then depending on your final percentage grade at the end, I'm going to assign grades, according to the scale, which again is pretty standard, I think. Okay. And so at the end, I do offer course or grade adjustments, okay? But I usually do this for the entire class together, okay? And so, unless it's a very special circumstance, I don't adjust individual grades. But what I like to do is that at the end of the class, I look at the overall class average, and if that's below, if that's below a C, so usually I make the cutoff at 75%, okay? And so let's say at the end of the class, the overall course average is a 71%, okay? And so what I'll do is I'll add percentage points to everyone's grade until the course average is at a C, okay? And so, in that case, where if the course average was 71%, then I'll add 4% to everyone's grade, okay? And so, before the adjustment, let's say that you're sitting at an 88%, and so that's a solid B plus. Then after the course adjustment, you're gonna have 88 plus 4, and so that's gonna put you at 92%, which is an A minus, okay? But I don't do that until the very end of the course, okay? And so, after the midterm exam, the course grades are gonna shake up a certain way, but I don't make the adjustment until the end, okay? And so, and I'll remind you too, because I know people are gonna ask me that throughout the semester, okay? But that's my policy on grading, okay? Okay, textbook. And so the textbook for this class is really good. And so I don't say that for a lot of my classes, just because I hate textbook publishers with a passion, okay? I think they've robbed like, thousands of dollars from me when I was a student, okay? I'm still bitter about that, even as an instructor, okay? But this textbook is actually really good. And so I think it does a really nice job explaining the concepts, and it has a lot of really nice figures, okay? So the course textbook, it is required, okay? Because, I think it's a really good one to help you, okay? But don't kill yourself trying to get this edition, okay? Or more importantly, don't kill your wallet, okay? And so if you can find an earlier version of this textbook, that's going to work just fine, okay? There hasn't been any major breakthroughs in heat transfer for a few dozen years, so even the first edition of this textbook is fine, okay? But with that said, I will post all my full problem statements, and I will push out the homework, all my lecture notes, okay? And so you don't need to look up anything in the book for that, okay? I just think it's a really nice reference to have, because it's outside of my lecture notes, I think the book does a nice job of describing things in greater detail, okay? And so what I always tell my students is, find a cheap one, okay? So it doesn't have to be this edition. And so if you can find a cheap one, or, if you just manage to find a free one when you're sailing on the high seas, that's fine too, okay? And so, I'll leave it at that, okay? So, try not to pay full price, but the textbook is very good. Okay? All right, course website. And so I'm going to go over the course website a bit more after this, okay? But I do plan on publishing a lot on the course website, okay? And so all of the lecture notes, all the lecture slides, the homework problems, homework solutions, exam solutions, study guides, basically any kind of content that I create for this class, it's going to be posted on Canvas, okay? You can find all the lecture recordings are going to be on Canvas as well, okay? So that's always going to be available to you, okay? Any announcements that I'm going to make for the class are going to be published through Canvas, and I think that automatically emails you, okay? And I think what a lot of you have noticed too is that I've also made a Discord server for the class, okay? And so, I've started using the Discord server, because of the virtual instruction, but I really like it. And so I think it's a really nice way for everyone to kind of interact with each other, outside of the classroom. And so I've seen students kind of ask questions on the Discord server, say, hey, I'm struggling with, problem 3 on the homework, and someone help me out. And then other students will answer them. Or I've seen study groups organized on the Discord. I've seen memes shared on the Discord, memes of me shared on the Discord. So I think it's all in good fun. Okay, so I think it's a great resource. So if you have Discord, I would highly recommend that you join and and use it. Okay. I will say that because there can be a lot of activity on these Discord servers, and I use my Discord account for my personal stuff too. Like I have my Dungeons and Dragons group and all my League of Legends groups on my Discord. So I will mute notifications on this Discord server, and so I'm not going to be checking it on a regular basis. But if you ever do need me to answer something on the Discord server, you can always tag me. And so my handle is very easy to remember. It's literally Professor. Okay, if you say @Professor and then you have a question for me, and I'll come and answer for you. Okay. But I really wanted the Discord server just to be a space for you guys, okay? And so where you guys can kind of talk and interact, okay? Another policy for Discord is that, even though I'm going to be on Discord a lot, you can direct message me on Discord, but I would ask that you kind of save it for emergencies, because again, I use this account for a lot of my personal stuff, and so I the first semester I did this, I kind of got flooded with Discord messages from students. A lot of times it'd be like 20, 30 students at a time be messaging me on there, and it kind of got ridiculous. And so you can message me on Canvas, but really only save it for emergency. So try to email me first. Okay. And you play League of Legends with me during office hours. I don't play PC League anymore. I play Wild Rift on the phone actually, but maybe we can play after outside of work hours where where the dean won't yell at me. Okay. But I'll give a tour of the course website after this. Okay, cool. Maybe we can all play together. Yeah, I'm not very good though, so I'll say that. All right, course policies. Okay, so homeworks. I do accept late homeworks, and so I get students that ask me this every semester. Sometimes even at the very end, but I do accept late homeworks, and so if you can't make a deadline, but you just have a few more problems to do, please finish it and turn it in. Okay. But my policy on late homeworks is that for each day that you turn it in after the due date, I do dock 10% off its points. Okay. And so I'd like to think that this is a fairly lenient policy, and so please, and so I want you guys, I really want you guys to do the homeworks. Okay, so please do the homeworks even if it's late. Okay, and I'll give you credit, subject to this policy. Okay, and if for some reason the Canvas site is closed, you can always email the homework to me. Right? And you can do this up to a week after the due date. Okay. Okay, so after a week, I won't accept it, but you can turn it to me, a week after it's due. Okay, regrades. I'm human just like everyone, so I make mistakes when I'm grading all the time. Okay, and so if I've made a mistake on grading your homeworks and the exams, please let me know. I'm always happy to look at things again. But again, I want you to do this, within a week after I've returned it to you. Okay. And a lot of times, people people just ask for more clarification on, why I graded things a certain way, and I'm always happy to answer those questions as well. Okay, but please be prompt about it. Okay. All right, emails. So a lot of you have done this already, so thank you for doing that. But if you're going to email me, please include EGME 407 in the subject line, just so I know who I'm talking to. Okay. Because I'm teaching 4 different courses this semester, and they're all kind of very different from each other. And so, if you email me with a subject line that just says help, please, a lot of times I won't know what you mean. So I don't know. I sometimes won't even know if you're a student in my class. Maybe you got stabbed or something and you needed someone to call 911. And so if you include EGME 407 in the subject line, then I'll at least know that, okay, this guy wants help on heat transfer. Okay, and so it really helps me organize my emails to do that, because I can get flooded with emails pretty easily. But if you do that, and you help keep me organized, then I do promise you that I'll give you a response as soon as I can. And so most of the time I can respond to your emails within 48 hours, a lot of times within 24 hours. So I do try my best to be prompt, except on weekends, because weekends, a lot of times I go out and it's hard for me to access emails. But yeah, but please, preface your emails with EGME 407, and it helps kind of keep my life organized. Okay. Okay. Any questions on this? Okay. All right. Academic dishonesty. And so, I always, this is always my least favorite part of the semester, because, I feel like my job here is not to be the police, but sometimes I kind of have to be. But just like any course that you take here, academic dishonesty will not be tolerated. Okay, and so and the reason we have this policy is that because the reason you're taking this class, and the reason I want you to be here is I want you to learn the material. Okay, and so I'm teaching this class on heat transfer, not because it gives me any kind of sick sadistic joy or anything like that. I'm teaching this material because I think it'll be really useful for you in your careers. I think it'll be really useful in your life. And also just because I think it's really cool. Okay, and if you cheat, and if you copy answers off someone, or you use Chegg or anything like that, end of the day, it's going to take away from your learning. Okay, and so I have this really hard line stance on academic dishonesty, because I want you to learn. I have cousins that are in college right now, and they ask me, so like, why are professors so hard asses on cheating? And it's like why don't you just let people do what they want? It's like, 'cause I just want you to learn. That's the only thing I want you to do. I just want you to learn the stuff, okay? But he's still a teenager, and so he's still learning. But so I have to take this kind of hardline stance, because learning I think is the most important thing, okay? But in kind of in exchange of that, I make this promise to you today that, if you ever feel like you're struggling in the class, if you ever feel like you're falling behind, even if you're falling behind for like 4 weeks, right? So let's say you can't make the lectures for some reason and you feel totally lost before the exam, I promise you that I will do everything I can to help you out and to support you, okay? Like I said, my job here is not to be the police. My job here is not to judge you. My job here is not to criticize you. Okay, so my job here is to facilitate your learning. Okay, my job here is to help support your learning as best I can. Okay, and so I've had students come to me, say, hey, professor, I honestly I haven't been able to attend the class, for the last 5 weeks, and I feel screwed for the exam that's tomorrow. Okay, and I think and that's really hard, I think, for a lot of students to come forward and say that, and I always applaud people's bravery in doing so. But again, I always tell the student, okay, so we have, 16 hours until the exam, let's come up with the game plan for you to, to get you, for you to do as well as you can. Okay. And so again, I'm not going to judge you. I'm not going to, comment on anything, right? That's not my job. My job here is to help you learn as much as possible. Yeah. Okay. All right, and so with that done, I do want to make you aware of the first homework. And so I know some of you have done this already, so thank you for that, okay? And so the first homework assignment is to simply just introduce yourself, okay? And so I want everyone to send me an email, okay? And the best thing about this is that you get full credit just for completing it. And so, you can share as much or as little information about you as you feel comfortable with. And so, you can even send me an email, say, hey, my name is this, give me credit, and then I'll give you full credit for that. Okay. And so I like this because I think it's, as an instructor, I think it's really important to learn about my class and to learn about what you guys hope to get out of this class and what your goals are. Because for me, that helps me design the course. It helps me tailor the course to make sure it meets everyone's needs. Okay. And so the more information you share about yourself, I think it's going to be more useful for me. Okay. But as much or as little as you share, you get full credit just for completing it. And so I like this too, because it kind of, everyone starts out with an A in this course, which is always a nice thing. Okay. And so if you're having trouble figuring out what to talk about, I have some questions here that you can consider. Okay. But again, you don't have to answer these questions. These are just questions to guide you, and so you can kind of talk about whatever you want. Okay. And if you send the email to me before the Sunday, January 30th by 11:59, then I can guarantee that you get full credit. Okay. And just like I said before, just as with any email, just make sure that you add EGME 47 to the subject line. Okay. All right, and so I think that's it for the syllabus information. And so are there any questions on anything that I talked about? Okay. All right, and so for the last 15 minutes of class, I do want to go over the course website. Okay. And so this is what you'll see on Canvas. Okay. And so here is the course website. Okay. And so I do want to take a quick just to show you kind of where everything is, where you can find stuff, and kind of how I've organized this website, because this is going to be a big part of the course. Okay. All right. And so when you first come to the course, you're going to be on the home page here. Okay. And so on the home page, you have the name of the course, just to make sure that you're in the right place. Okay. Here's some information about me. Excuse me. And if you click on my name, you can see it comes to this weird Tinder profile that I made for myself. Okay. And so you can read that if you want. I always find it embarrassing, so I don't read it. I don't read it again. Okay. And so you can see the times that we're supposed to meet, and of course everyone got the memo because we were all here. Okay. And the course location, after the first 2 weeks, is going to be in E201. Okay. All right. So here we have a description of the course. Here we have the learning objectives that we talked about. Okay. Here you can download the syllabus, and so the syllabus will cover all the information that that I just covered. Okay. And so if you need a summary of that, you can click on that. Okay. Here are all the Zoom links. Okay. And so you're all on the Zoom call for lecture. Okay. But if you want to come to office hours, I have a separate link for each of those, and so you can click on these links. and it'll automatically open Zoom for you. Okay. The nice thing about this class is that I did teach this class virtually 1 year ago. And so if you want to view all the lecture recordings from then, I still have them all saved in a playlist. Okay. Okay, so you can view all the lectures here. Okay. Right, and so that's available to you. I will be recording all the lectures from this semester too, and I'm going to add them to the same list. But if you want to look ahead, or if you want to see where all of the YouTube recordings are, they're at this link. Okay? If you want to join the Discord server, here's the link to do so. Okay, and so if you have a Discord account, you click this link, it'll automatically join you to the server. Okay. Right. And so the last piece of information I want to point you out to on the homepage is this course outline. I like to call it the weekly viewer. Okay. And so here's kind of a week by week breakdown of what I plan to cover, for this course. Okay. And as we go through the semester, each of these weeks here will become clickable. Okay. And so you can see I've already created the page for week 1. And so if you click on week 1 right here, okay, you'll come to the page for that. Okay. And, I make these pages to show you kind of everything that you need to know for this week. Okay. And so for each week, what you'll see here is that, I have a title of the topics for that week. I have the, a short description of what we're going to learn. Here are all the learning objectives. Okay. You can find links to the recorded lectures for that week. Okay. And so after this lecture is done today, then this link will become active with the YouTube link for that, for that lecture. And then our Wednesday lecture will go right here. Okay. And so if you wanted to rewatch a certain lecture, or if you missed a certain lecture, I like this organization because you can say that, hey, I missed the Wednesday lecture of week 1. Let me go to week 1 right here. And then I'll click on this link right here, and then you can watch the lecture from there. Okay. All the assignments for that week will be summarized here. And so, you can click on these. And if you click on this link, it'll take you to the assignments page where this gives you, for this one, there's nothing to submit, but, for other homework assignments, there'll be a button for you to submit your work. There'll be a link for you to download the problem set here as well. Okay. And then besides that, here are all the documents that are needed for the week too. Okay. So you can see here, I have a link to the syllabus. I have a link to the slides that I just covered. And then the lecture notes that we're going to start on Wednesday, I have a link to those as well. Okay. And so I always make the update the weekly, the weekly view, the weekly page, on the Friday before that week. And so if you want to pre-read or read the notes, ahead of the week, then you can do so starting on Friday. Okay. So I usually do all these things on Friday. Okay. And so, if you kind of follow the course kind of week by week, you can kind of find everything you need from the weekly viewers. Okay. Question. So are there assigned suggested readings from the textbook? Great question. So I normally don't assign readings from the textbook, just because, people from my classes tend to have different versions of the textbook. But I do have, but the sections that I list out and in my notes, and the way my notes are organized are very closely related to the textbook. And so, and a lot of times I use kind of the exact same section headers. And so, if you kind of need more clarification from the textbook that's outside of the lecture notes, you can just go to that same section with the same name, and then you can find more information there. Yeah. So I usually, I know that when I had assigned textbook readings when I was a student, I would do the readings, but a lot of times it would be hard, without the context or without kind of the professor kind of explaining stuff. So, I would suggest that, if you want to look at the material, pre-read it, I would look at my lecture notes. I do make an effort to make my lecture notes, as readable and as easy to follow as possible. And then only refer to the textbook when you need more detail. Or more examples, right? So another reason this textbook is great because it has a lot of examples that that can help with your learning. Yeah, a lot more examples than what I can cover in the class. Okay. All right, so let's go over the different links here that we have for the course website as well. Okay, so next we have announcements. Okay, and so you can find all the announcements for the course here as well. Okay, so again, all the announcements will be emailed to you, but if you want to view the announcement again. Say you deleted the email on accident, you can find that here as well. Okay. Next, we have the assignments tab. Okay, so the assignments tab will, this will show you all of the assignments that are coming. Okay, and it'll show their due dates. Okay. I want everyone to be careful, and so maybe everyone's figured this out because we've been using Canvas for a while, but there are 2 dates here, okay? And so there's a date that tells you when the assignment is available until, okay? And then there's the due date, okay? This due date is when you need to turn things in by, okay? And so if you turn things in after the due date, then I'm going to start to mark it late, okay? The reason, and what you'll see often is that the available until date is usually 1 week after the due date, okay? And so the reason for that is to allow people to turn in their assignments late, okay? And so I've had people be confused when they turn in their assignments by the available until date, and then they wonder why they got marked late, because it was actually due a week sooner than that, okay? And so turn things in by the due date. I have the available date, there just to let you turn things in late, okay? All right, next we have grades, okay? And so from this tab, you can kind of see a summary of your grade breakdown, okay? And so on this test student here, he hasn't sent me an email yet, so I haven't given him a score here. But from here, you can see a breakdown of how you did on every single assignment, and then what that tells you for your total grade at the moment, okay? And so this is a great way to kind of keep track of how you're doing in the course, okay? Next, we have the people tab. And so here is a list of everyone in the class, okay? I think you can click them and you get some information on them, okay? So if you want to get someone's email address to help organize a study group or something, this is how you can do it. And then probably outside of the homepage and the weekly viewer, this is probably the page you're probably going to come to the most. And so these are all the files that I'm going to, that I'm going to post for the class, okay? And so every lecture note and every syllabus and every homework assignment, you can find all that stuff here, okay? And so if you're having trouble finding a certain file, so, say you're looking for the PDF or homework 2, you can just come to this, come to the files link here, and you can find it here. So I haven't given out the first real homework assignment yet, so this is empty, okay? But if you go to the lecture notes tab here, you can actually find all the lecture notes for the entire semester, okay? So usually this is the first time I'm doing this. Usually I wait to upload the lecture notes until the week before, but students have kind of requested me a lot to kind of get ahead on the reading, just so they can kind of see what's coming. And so, if you want to see, all the lecture notes upcoming, you can find them all here, and they're numbered. They're numbered in the order in which we're going to tackle them. Okay? And so right now we're on 00, which is the introduction slides, and then on Wednesday we're going to start covering lecture notes 01. Okay. And then if you click on this link here, support resources, I think this gives you some support stuff, right? And so here's some Cal State Fullerton specific resources for you to do. So you can access CAPS here, you can access DSS, and all that stuff. Okay. Okay. And so that's the course website. And so are there any questions on this? Okay, all right. And so if there's no more questions, then that's all I had planned for today. Okay, so we're going to end 4 minutes early today. Okay, so there's an introduction to the course. Okay, so hopefully that answered all of your questions. Okay, and so on Wednesday we're going to start working on content. Okay, all right. So thank you everyone for coming today. I know it was I know everyone's sick of Zoom, but I'm glad everyone could make it to the Zoom call today. Okay, so have a great rest of your afternoon. If you have any questions or anything, please feel free to email me. And if not, I will see everyone on Wednesday.
Thank you, Professor.
Thanks, guys.
Thank you, Professor. Have a good one.
Thanks, you too.
Thank you.